So take a look at these. Take a look at f. F is the original. F prime is the derivative. That's how we started, number 1, number 2, number 3 in the practice, and that's how we finished. Is there a rule that would shorten our, right? Because on your practice, you probably had like this much work, right? We want to try to shorten that a little bit, right? Because if you're trying to do every problem like that, will it work? Yeah. But if you have 8 of them on a test, it's going to be hard to finish, right? So let's figure out a way to shorten your work to make it easier, make your life easier. So is there a way, how do I go from one to the other? What are you noticing? What do you wonder? What do you notice from one side to the other? And if you know the answer, kind of zip it. If you know the rule, don't say anything. But if you don't know it, because I know some of you do know the rule, what are you noticing? How can we go from left to right? Find the derivative. What are we doing here? Is there anything you're noticing from one side to the other? Nothing in common?
Losing an x?
Multiplied by the exponent.
So go back to what Tyler said. Tyler, what did you say before? I'll come back to you, Damien, but what did you say, Tyler?
We're losing an x. Like 1 has 2x, the derivative is 2x squared becomes...
The power, right? The biggest powers are going down, right? Number 1 had a power of 1, right? X to the first, no power. Number 2 at x squared, 1 power. X squared, x to the first. X to the first, no power. We're losing a power every time. Power's going down. That's part of the rule. No, what were you going to say, Damien?
Multiplying by the exponent and removing an x.
So yeah, combining what you said with what Tyler said. Subtracting a power, so the power goes down. Okay? So definitely power is going to go down. So if I'm taking the derivative, power is going to go down by 1. Okay, so the power is going to go down by 1. So this is on your paper, you don't have to write this part down. But, so let's say we have a power. When we find the derivative, we're going to subtract 1 power. So if it was 2, it's going to be 1 after, sorry. If it was 3, it's going to be 2 after, right? We're subtracting 1. And then what did you say, multiply by? Whatever the old or the new exponent? Old exponent. Yep, whatever the old exponent was. That's the power rule. That's the rule that you're going to use most of the time when you're finding derivatives. It's called the power rule for finding a derivative. Okay? We subtract 1 from the power. So let's start with this guy. If I subtract 1, right, it becomes a power of 1. And then I multiply by the old power, which was 2, right? Why does the negative 5 just vanish? Why does this negative 5?
No x.
Because it doesn't have a power, right? It doesn't have a power. So anything without a power, they vanish. If it just had a power of 1, has no power, right? X squared plus 3x minus 4. All right, so if I subtract a power from this guy, I get 1, right? And then I multiply by the new power, or by the old power, sorry. That's how I get this guy. This guy had a power of 1, so now it becomes nothing. That's why there's nothing over here. And then the old power, so what was the old power here? So it did get multiplied, right? But it just, anytime you multiply times 1, it just stays the same. That same thing happened here. This guy here, power went down, multiply old power times whatever's in front. That's how I get negative 8. Okay? That is the power rule. That is the most, you're going to use it probably on every derivative problem you do. Probably anytime it asks you for a derivative, that's what you're going to use. You might use other rules as well, but power rule is always something we come back to. So look at, Look at each of these. You could probably do each of these in 5 seconds each, compared to how long did it take you to do all 6 of them if you've done it already. Probably took you at least 20, 30 minutes, right? How would you like to have literally cut it in fractions, right? That's what the power rule does. That's what the power rule does. Okay, so let's take a look at today's. So the first one is the power rule. If n is any number, so if the power is any number, positive, negative, fraction, doesn't matter, then the derivative, then when you find the derivative, you're going to do this, which we just did. Subtract 1 from the power, multiply by the old power. Okay, let's look at 1a. So the old power was 5, right? So let's find the derivative. So the power rule says whatever the power was before, subtract 1. So what is the new power going to be? 4. And then what do we do with that old power? Multiply it by whatever was in the front, right? Well, what was in the front of x that we never write? A 1. So 1 times 5 makes 5. B kind of throws a wrench. Yeah, we got to get rid of the root. So how do we get rid of the root? Well, we change it to a fraction power, 2/3. Right? So the old power was 2/3. What happens when I subtract 1 whole from that? What do I get? Yeah, you get negative 1/3, right? If I subtract 1 whole from 2/3, I get a negative number, right? That's okay. Negative 1/3. I can have a negative power. And then I multiply by the original power, right? 2/3. So you can write it like that. Or you can write it like this. Because really it's multiplying times 2 and dividing by 3. That's 2/3. And we usually don't like to finish with a negative exponent, right? So how do I make that exponent positive? Say it again. Yeah, move it to the bottom, right? Move it to the bottom. So really this is the correct way to write it. They're all the same, but the last one here is the most correct answer, right? The most correct answer.
With a cube root.
What's that?
Cube root.
With a cube root, yeah.
Instead of the third.
Yeah. You got to take the good with the bad. I know, yeah. I know. So like if this was a free response question, I would take any 3 of those answers. Multiple choice question though, you're only going to have 1 of those 3. They're not going to give you all 3 because it's 1 correct, right? So you just know that they're all the same. That's all I care about. Yeah. If I were grading this on a quiz or free response, I'd give you credit for either of the 3. Okay. All right, so C. Well, it's 1 over. So it kind of looks like this last one that we did, right? 1 over, this last one had 5 over x, right? Well, I don't like fractions when I'm trying to find the derivative. So how can I change this so that it doesn't have a fraction? It's not 1 over x to the 4th. Move it up, right? So to move it up, I can do that as long as I do what? Make the exponent negative. So it would be 1 times x to the negative 4, right? Use the power rule. Subtract 1 from the power. So if I subtracted 1 whole, how many powers would I have? -5, yeah. Not -3, -5 because you're subtracting, right? Multiply by the old power. So the old power is going to multiply times what was in front. So -4 times 1 is -4. Again, that's okay, or you can move it back down. Either one of these is okay.
Yeah, now I realize that one.
So, like I said, either one of them is okay, but they usually don't have negative exponents on multiple choice. And most of the time when you see these, it's going to be a multiple choice question. Okay? Constant. The derivative of any constant is 0. Why? Why is the derivative of any constant? So a constant is just a number, positive, negative, fraction, no variable. So why, when it has no variable, is the derivative always going to be 0?
You get rid of it.
Because the rule says we subtract a power, right? If it doesn't have a power, it goes away, right? But think about, so what are the 3 words that I told you guys to remember anytime you saw the word derivative? Slope, that's one of them.
Tangent line?
Tangent line, right? Slope of the tangent line.
I remember.
There you go, right? Change over time. Change over time. So a constant, is that changing over time? No, it's constant. So it's got no change. No change means slope is 0. That's why it always has. No change, slope of 0. No change over time equals slope of 0. If something doesn't change over time, it's going to have a slope of 0 because slope is change over time. Okay. So f prime equals 0. Okay. So anytime you're finding derivative of a constant, it's always going to be 0. This one's the next one, constant multiple. It's an offshoot of the power rule. So really this is a power rule. So don't even think of this one as a separate rule. Just constant multiple. Think of it as a power rule. So this one I just think of the power rule. The one we just did. Okay. So old power was 7, so I subtract 7. I subtract 7 minus 1. I get 6, right? And then what do I do with that old power? Multiply it by 5, what it was already there, right? So that's 35x to the 6. I don't want fractions, right? Especially don't want my variable in a fraction. So how can I rewrite this so the variable isn't in a fraction? Make it negative, right? So let's do that first. Let's move it up. So I get 4x3 over 5, which is the same thing as 4/5 x3, right? Say again. Oh, sorry, negative, yeah. Thank you. Yep. Do you want to separate your coefficient from your variable when you're doing derivatives? So there's nothing wrong with this guy or this guy. There's nothing wrong with them. But when I'm using the power rule, I want my coefficient over here and my variable over here. It's easier to use the power rule that way. So subtract a power. So if I subtract a power, it's going to be x to the negative 4, right? Remember, 4/5 was already there. And then what do I multiply by? Negative 3, right? Negative 3. Or negative 3 over 1 since it's a fraction. So you get negative 12 over 5 times x to the negative 4. Which, put it back in a fraction. That's the better answer there. It's back in a fraction, like it started. You always want to put it back like it started. And then you want to do take care of all the negative exponents. Okay. The two ones that are hardest to use, I don't want to say hardest, but the most difficult where I have students kind of making most mistakes is two ways. This kind of thing, this one right here, and when the when the power is a fraction. When the power is a fraction, and this one here, or it's kind of, they're connected together, and then you have to separate, use the power rule, and then put back together. Those are the ones that give students the most fits, the ones I've noticed. Okay? Other than that, the power rule is pretty standard. Okay, so sum and difference rule. When I'm adding or subtracting terms, I can find the derivative of each term separately. You can do it together, or you can do it all together. Okay? So how do we do it? We just use the power rule again. So turn it over. Let's look at 3. Example number 3. So what that rule says is each one of these guys is its own term, right? So really this is 4 different problems in one. You could separate them or just do them separately. So for example, what's the derivative of the yellow? 3x squared, right? 3x squared. What's the derivative of the green? 8x. Positive 8x. What's the derivative of the aqua? -2, right? It just drops the x. And what's the derivative of the last one, the kind of the baby blue color? 0. You don't have to write that 0. Is it wrong? No, but you don't have to write the 0 because 7 is a constant. Derivative of a constant is 0. So B is kind of the one like I was saying before. This one kind of gives students issues. And it's not because they don't know what to do, it's because they kind of forget their algebra. Okay, so let's go over this one at a time. So if you know how to do this, great. But I want to I don't like fractions. I like to separate fractions from what I'm doing. Okay. So let me deal with the yellow first. Let me deal with the yellow. So the first thing I'm going to do is I'm going to distribute. They kind of didn't simplify this guy. I'm going to give this guy a power of 4, and I'm going to give this guy a power of 4. So they didn't simplify it. So it's really 3. What's -2 to the 4th? What's -2 times -2 times -2 times -2? 16, yep. X to the 4th. Okay. Again, I'm going to do what I did earlier. I'm going to move this guy up. And it's a -4 power. Now find the derivative. I did that. That was like pre-work. It's not even finding derivative. It's kind of just simplifying it, rewriting it a lot of times. A lot of rewriting we do when we're finding derivatives. Okay? So the next thing I got to do is actually find the derivative. Use the power rule. What power is that going to be? -5, right? -5. And then I got to multiply the old coefficient by the old power. So I get -12/16, right? What is -12/16 reduced to? -3/4? Yeah. -3/4 x to the -5. That's the derivative of the yellow. Now I got to do derivative of the green. So isn't there a 1 in front of the x here? There's a 1 that we don't write in front of the x, right? So really, this is 1/2 times x. The x is already at the top, so I don't have to move it to the top. So what is the derivative of 1/2 times x? Just 1/2. That's the derivative of the yellow. So I got one derivative there. Let me see, let me not highlight it. So I got one derivative here, one derivative here. Yeah, so it's going to be minus, right? Yeah, sorry, I should have put that minus in front. Thank you. No, that's a big deal. Yeah, I dropped that one. All right, so now what's the derivative of 1/4? 0. Put them all together. Negative, oops, so derivative, negative 3/4 x to the negative 5 minus 1/2 plus 0, right? So these are more likely going to be multiple choice questions that you see. This answer right here is never going to be one of the multiple choice answers. It's got a negative exponent. This is the answer you're going to see when you're answering. This is the answer you're going to see. They're both right. There's nothing wrong with them. They're both right. But the bottom one is the one you're going to see on a multiple choice test. That'll be A, B, C, D. That'll be the one you're going to choose. If you're looking for this guy here, you won't find it. Right? So you just got to know all that good stuff. You got to know that they're the same. Okay. Okay, so we did this the last one where we're finding the equation of the tangent line. We're doing it again. The only difference is we don't have to use the long limit equals as h approaches 0. We can use the power rule. We're going to take this problem and we're going to shorten it by using the power rule. So when we find equation of tangent lines, what do we need? What are the things that we need when we're finding equations of tangent lines? What's the big guy? What's the big thing that we need? We need really two things, three things. What's the big one that we need? Derivative. So we need a derivative. Derivative. Yep, we need derivative. What else do we need? Right. Slope. We need a slope. And then what's the last thing that we need? Starts with a P. Point. Right? Could we use a y-intercept? Yeah, but you're making your life a lot harder because they already gave us half of a point. Okay? So let's start with the derivative. So what's the derivative of 4x cubed? 12x squared. Minus. What's the derivative of negative 6x? Negative 6. What's the derivative of positive 5? 0. Okay, so that's number one. Now let's do number 2. How do I find the slope at x equals 2? Plug it in. Plug it into the original or plug it into the derivative? Derivative. Twelve times 4 minus 6. 48 minus 6 is 42. There's my slope. Yeah, it's a pretty rising pretty fast. And then last one, point. I need a point. I have half of it, don't I? I know x is 2. How do I find y?
Plug in x to the original.
To the original. Very good. Plug it in back to the original.
Bring it back.
2, 2. So we get 4. See, 2 to the 2 cubed is 8 times 4 is 32. Minus 12 plus 5. 25? Okay. So use point slope. Y minus y1 equals mx minus x1. Okay, so y minus y1, so our y is 25. Our slope is 42, and our x was 2. You can convert that to slope intercept. Sometimes they'll specifically say, I want it in slope intercept form. Well, just convert it. To convert it, you just set it equal to y, right? Distribute the 42, add 25 to both sides, and boom, it's in slope intercept. Don't ever start in slope intercept. That's way too hard. Okay? It's not hard, but it's just giving yourself more headaches for the sake of nothing. Do it this way first, because this way will be easiest. This way is always easiest. Start with point slope, and then go from there. Okay? Okay. Number 5. I have two things multiplying times each other, two binomials, right? I have 4x squared plus 1 times 2x minus 5, right? I don't have a product. There is a product rule. There is a product rule. It's on the next page. But let's pretend we don't know that. How can I use the regular power rule to solve this? Yeah, FOIL, right? Multiply first times the outer times the inner times the last. Or distributing, it's how you distribute binomials. So first is 4x squared times 2x, 8x to the third. Outer, 4x squared times negative 5. Inner, plus 2x. Last, negative 5. That's the original. It's not the derivative, it's the original. Now I can use the power rule. The derivative of 8x cubed is 24x squared. The derivative of negative 20x squared, negative 40x. The derivative of 2x, positive 2, and the derivative of negative 5 is just 0. Now on the next page, I'll show you the product rule. Sometimes you have to use, for this one, it doesn't really matter. You could have used the product rule or we could have done that. Doesn't matter, but there's some problems when you can't avoid the product rule. So there's 2 more rules we're going to cover today. The product rule and the quotient rule. If we can get, yeah, we'll be able to finish. Product rule, quotient rule. Okay, those are the 2 other rules that we have. Okay? Product rule. Product rule says if you're multiplying 2 different functions, how do you do it? Well, you take the original, the first function, and multiply it times the derivative of the second. So let me annotate this a little bit.
What? Oh, wait, I think I understand.
So this is the first function. This is the derivative, dy over dx of the second, plus the second function times the derivative, dy over dx of the second function. Okay? So, first function is u times the derivative of the second function. Plus, do you want me to erase that? Does that make it worse?
Let me write it down first.
Wait,
It low-key
there's
kind
two
of,
derivatives of the second function.
Oh, is there?
One's supposed to be the first.
This was supposed to be the first. Sorry.
Adding du is supposed to be.
This was the first.
Okay, that makes a lot more sense.
Okay. Yeah, that was just my mistake.
low-key makes actually, actually makes kind of sense.
What is, good, great question. What is dy over dx? You're going to see it a whole lot on the next quiz or test.
Just means derivative.
It just means derivative. It just means derivative. So instead of writing the word derivative, my handwriting's bad enough, so I just say dy over dx. dy over dx means derivative. Okay? So let's follow this. So before we even do anything, what's wrong with this problem? A. There's something not very wrong with it, but there's something that you're going to run into that it won't make you happy if you start without addressing it. Square root, yeah, square root. We don't like square roots. When we're doing derivatives, we don't like square roots because there's no square root rule, but we do have a power rule. So instead of, so let me rewrite this. How can I change it so that I do have a power instead of a root? 1 over 2. Give it a power of 1 over 2. Everything else is okay. So can you do FOIL like we did last time? Yeah, you could, and do it that way. That works. Nothing wrong with that. But I'm going to show you how to use the product rule. So yellow is the first function, green is the second function. So let's look at the rule. The rule says rewrite the first function. So I'm just going to rewrite it. I'm not going to do anything with it. Just rewrite it. Then times, okay? The derivative, dy over dx, of the second function. So what's the derivative? This should be a minus, it looks like a dot. Okay. 15x squared, and what's the derivative of negative 7? So just 15x squared, right? Plus the reverse. The second function, rewrite the second function. Times the derivative of the first function. So what's the derivative of the first function? What's the derivative of 3? 0. How do I do derivative of 2x to the 1/2? Minus 1 from the power, so what power would it be? Negative 1/2. And then what do I multiply 2 by? So what do I get when I multiply that? 1. So I get 1x to the negative 1/2. 1x to the negative 1/2. As much as you can do. So up until this class, your teachers have always said, show as much work as you can. Show as much work as you can. This class, I'm going to say try to do as much in your head as you can. Okay? Because if you write down everything, it's going to be cumbersome. So so use your mental math as much as you can in this class. Okay? So, how far do we need to go? The answer is until we get an answer. This is usually going to be a multiple choice question. So go until you get an answer. So if that's one of the answers, A, B, C, or D, stop, you're done. Probably won't be until you distribute. So I got to distribute the one term to the two terms, which is a version of FOIL. So you get 15 times 3, which is 45, x squared. 15 times 2 is 30, x. How do I multiply powers? So if I have x to the 1/2 times x, you add them, right? So what is 2 plus 1/2?
5/2.
5/2 or 2.5, yeah.
It's 4.
Okay, so I get x, so I get 5x over here. What's 3 plus negative 1/2?
5/2.
5/2 again. Or 3 minus 1/2 is 2.5, right? 5.5. 5/2, sorry. And then multiply. No. And then you get that right there. That right there that we just did was probably the hardest part of the problem, and that's just fractions. When did you do fractions? Probably 5th or 6th grade, right? That's the hardest part about some of these.
Actually, the fractions are fine. It was multiplying and dividing them.
Yeah.
So doing all of it? Yes.
Okay.
I can add fractions.
Last thing,
It's not well.
this needs to move. Oops.
Can we combine?
We can combine like terms, good. And that needs to go to the bottom.
I'm gonna need visuals. I can't do word problems with fractions.
Okay, so we get 45x squared. Combine these two, we get 35x to the 5/2. And then the last one, the x just has to move to the bottom. That's the answer that most likely would be at one of the A, B, C, D multiple choice. Okay. So sometimes that's the hardest. I have students every year who can do this. They're like, okay, that makes sense. I can do this part. But they can't get to here. And I'm like, that to get from there to there, that has nothing to do with calculus, right? Calculus was done after this step here. Okay, so that's, again, that's the part. In this class, you're going to find the hardest thing is usually not the calculus. It's everything else. Okay? All right. Do this one on your own. Do B on your own. This one's a little more tame. This is a little more tame. That's why I gave this, that's why I gave the second one to you. So the derivative, so we start with, you go the first term times the derivative of the second. The derivative of the second is just 5. Plus the opposite. The second times the derivative of the first. So let's say I'm on a test or a quiz, and I forgot to write it on my card, and I accidentally do it backwards. I accidentally do this guy here. Would it be okay if I forget which one to do first? So I accidentally do, so in other words, because this happens all the time and I get this question during the quiz and I can't answer it. What if I do that? Is that okay? Is that the same thing you have? Does it mean the same thing you have? Yeah. Yeah, why? Why does it mean, what's the reason why it's the same thing you guys have? Because of the? When can you change order? When is changing order okay and when is it not okay? When you're adding or multiplying, right? When I'm adding or multiplying, order does not matter. When I'm subtracting or dividing, order does matter. Okay, the last rule we're going to talk about is the quotient rule. Order matters on that one because we're going to be dividing and subtracting. Okay, but for this guy, since we're just adding and multiplying, order doesn't matter. You could flip-flop them, it's okay. Oh, and then probably should distribute here and distribute here first. Outer, inner, last. So I get 15x minus 10x squared plus, and then over here I get 12 minus 16x plus 15x plus plus 20x squared?
Yes.
20x squared. Combine like terms?
Minus 20.
Minus 20x.
Minus.
There we go. Feel better now? No, I know. I'm the same way. I'm the same way. Sometimes something just like nope, nope, nope. Change it before it just like irks you, right? It's good. It's good.
They took damage over it.
Okay. Combine these two guys. These three guys. Sorry. What do we get? 14 plus 14x plus 12. That's y prime. Okay. Okay. So we're not going to get into this one because it takes a little longer than whatever we have, 8 minutes or so, 7 minutes or so. But I just want to look at it. Look at this guy here. Shouldn't those look familiar? The V's and the du over dx and the w, the u's, right? We just saw those, right? So you should know what they are. It just has a division and a subtraction instead. So this is the bottom function, right? V is the bottom. Derivative of the top minus the top times the derivative of the bottom, right? Over the bottom squared. Okay? I've heard this, and I tell students this. Sometimes it helps you remember. So, say low. You know what I mean by low? It's the bottom, right? Times d high. What's d high mean? Derivative of the top minus high. And what would this one be called? D low. Low D high minus high D low over low low. Okay? That's if it helps, it helps. Low D high minus high D low. Because remember, for this one, order is going to matter. So if we accidentally get them mixed up, it's going to make a big difference. Okay? So that's what we'll finish tomorrow. We'll finish this tomorrow and then, yeah, go from there.